Assalamu alaikum students, let's learn chemistry with Mir Sajad, your chemistry teacher. Today we are going to discuss about the concept of electron gain enthalpy. This electron gain enthalpy is also an important property of an element like atomic size and ionization energy. As you know that ionization energy represents the tendency of an element to lose electrons. In a similar manner, the tendency of an element to gain electron is known as electron gain enthalpy. So electron gain enthalpy represents a tendency of an element to gain electron. For example, if we have a neutral gaseous atom, that's X, let this X is a neutral gaseous atom. Now if we are adding an electron, extra electron to this neutral gaseous atom, it results in the formation of a negatively charged ion that is known as anion. So it will form X negative ion. But during the addition of this extra electron to the neutral gaseous atom, there also occurs some energy changes. And those energy changes which takes place during the addition of an extra electron to the neutral gaseous atom is known as electron gain enthalpy, and it is represented by EA. So EA is the electron gain enthalpy, or it is represented by delta HEG, that is electron gain enthalpy. So we can define the electron gain enthalpy as the energy change that takes place during the addition of an extra electron to the neutral gaseous atom, and as a result to form a monovalent anion. Thus electron gain enthalpy is defined as the energy change that takes place during the addition of an extra electron to a neutral gaseous atom so as to form a monovalent anion. Now this electron gain enthalpy may be either negative or positive, that is EA will be either negative or it will be either positive. Electron gain enthalpy is negative for the exothermic processes. So if the addition of electron involves the release of energy, then the value of electron gain enthalpy is negative. Whereas if the addition of an extra electron involves the absorption of energy, then it is endothermic in nature. So we can say that for exothermic processes, the value of EA is negative and is known as negative electron gain enthalpy. Whereas for endothermic processes, the value of electron gain enthalpy is positive. Now, whether the value of electron gain enthalpy is negative or positive, it depends upon the nature of element. So let's explain it. It must be noted that for most of the elements, the value of electron gain enthalpy is negative. For most of elements, the value of electron gain enthalpy is negative. That is, for most of the elements, energy is released during the addition of electron. For example, if we have to add electron to the isolated chlorine atom, it results in the formation of chloride anion. And experimentally it has been found that the value of EA for this process is minus 349 kilojoule per mole. That means during the addition of an electron, the neutral chlorine atom, 349 kilojoules per mole of energy is released. So chlorine has the negative electron gain enthalpy. But for few elements like noble gases, the value of electron gain enthalpy is positive. That means for noble gases, energy is absorbed during the addition of an extra electron. Actually, these noble gases are stable elements. They have the stable electronic configuration. Hence, in order to add an extra electron, we have to add the new shell, and it is difficult to add the electron or to add the electron in the new shell. Hence, these noble gases have the positive values of electron gain enthalpy. Like ionization energy, the values of these electron gain enthalpy also depends upon some factors like atomic size, nuclear charge, and electronic configuration. So value of electron gain enthalpy depends upon following factors. 3 factors पे डिपेंड करता है. Number first is the nuclear charge. It must be noted that greater the value of nuclear charge, जितनी nuclear charge ज़्यादा होगी, उतना ही ज़्यादा attraction होगा between the incoming electron and the nucleus. For example, अगर ये हमारा atom है, so we are adding the electron to this atom. अब जितना ये न्यूक्लियस स्ट्रांग होगा, उतने ही स्ट्रांग फोर्स से ये इस इनकमिंग इलेक्ट्रॉन को अट्रैक्ट करेगा. Hence, we can say that greater the value of nuclear charge, greater is the attraction between the incoming electron and the nucleus. Hence, more will be the value of the negative electron gain enthalpy. So we can say that greater the value of nuclear charge, greater is attraction between incoming electron and nucleus. Hence, more will be the value of negative electron gain enthalpy. Now let's discuss about the effect of atomic size. Second one is atomic size. It must be noted that more the size of an atom, less will be the attraction between the nucleus and the incoming electron. क्योंकि जितना size बड़ा होगा, उतना nuclear force कम होगा. Hence, less will be the value of electron gain enthalpy. So, more the size of an atom, less will be the nuclear force offered on incoming electron. क्योंकि जितना साइज ज्यादा होगा, उतना ही न्यूक्लियस को उस इनकमिंग इलेक्ट्रॉन को अट्रैक्ट करने में डिफिकल्टी होगी. Hence, less will be the value of negative electron gain enthalpy. Now the last factor is electronic configuration. It must be noted that the elements with suitable electronic configuration have either little tendency to accept electron or will have no tendency to accept electron. Hence, their values of electron gain enthalpy will be either very little or they will be 0. So, the elements with stable electronic configuration will have either little or no tendency to accept extra electron. Therefore, the value of electron gain enthalpy will be either little or 0. So these were the factors on which the value of electron gain enthalpy depends. Now we will discuss about the trends of the electron gain enthalpy down the group and across the period. trends in the value of electron gain enthalpy. First of all, we will discuss about the periodic trend. That is, if we move across a period. So across a period, nuclear charge increases. Nuclear charge increases and atomic size decreases. Both these factors, that is increased nuclear charge and less atomic size, tends to increase the value of electron gain enthalpy, because जितना ही न्यूक्लियर चार्ज ज्यादा होगा उतना ही जो न्यूक्लियस है इट विल अट्रैक्ट द इनकमिंग इलेक्ट्रॉन. सिमिलरली जितना ही एटॉमिक साइज कम होगा उतना ही स्ट्रांग फोर्स से न्यूक्लियस इनकमिंग इलेक्ट्रॉन को अट्रैक्ट करेगा. एज अ रिजल्ट वी कैन सी दैट बोथ दीज फैक्टर्स, दैट इज इंक्रीज इन न्यूक्लियर चार्ज and small atomic size, leads to the increase in electron gain enthalpy. So simply we can say that when we move across the period, there is increase in the value of electron gain enthalpy. However, on moving across a period, some anomalies are observed. Particularly, the anomalies are observed by the elements of group second, group 15 and group 18. It is because अगर हम group second की बात करते हैं, all the elements of group second have the electronic configuration of ns2. The valence electronic configuration of these group second elements is ns2. That means all the elements of group second have the completely filled s subshell. Completely filled s subshell. Whereas all the elements of group 15, that is nitrogen, phosphorus, arsenic, antimony or bismuth, they have the valence electronic configuration of ns2 and p3. That means their s subshell is completely filled and this p subshell is exactly half filled. Similarly, if we take the example of group 18 elements, that is noble gases, they have the general electronic configuration of ns2 and p6. That means these noble gases have completely filled s subshell and completely filled p subshell. That is completely filled p and s subshell. As you know that the completely filled subshells and the exactly filled subshells leads to the stable electronic configuration. Thus, we can say that the elements of group 2, group 15 and group 18 have the stable electronic configurations, and as you know that the elements with stable electronic configurations have less values of electron gain enthalpy. So that's why the elements of these groups shows anomalous behaviors in their respective periods. Now we will discuss about the group trend. Group, that is when we move down the group, it must be noted that when we move down the group there is increase in atomic size. Increase in atomic size or increase in the screening, and both these factors, that is increase in atomic size and increase in the screening, leads to the decrease in the magnitude of nuclear force. Magnitude of nuclear force on incoming electron. Thus, we can say that it leads to the decrease in the value of electron gain enthalpy. So simply we can say that when we move down the group, there is decrease in the value of electron gain enthalpy. So this was about the electron gain enthalpy and the trends in the values of electron gain enthalpy. इस टॉपिक से क्वेश्चंस पूछे जाते हैं इन योर बोर्ड एग्जामिनेशंस एज वेल एज इन द कंप्यूटर एग्जामिनेशंस. होप आपने अच्छे से अंडरस्टैंड किया होगा. मेरे साथ कनेक्टेड रहने के लिए मेरी यूट्यूब चैनल दैट्स केमिस्ट्री विद सजाद सर सब्सक्राइब कीजिए, ताकि आपको फ्यूचर में भी केमिस्ट्री रिलेटेड मोर इन्फॉर्मेटिव वीडियोस मिलते रहेंगे. टिल देन, थैंक्स एंड हैव अ नाइस डे.